Zuber by day, but he's a meetup and conference organizer by night. And he's going to talk to you about caching techniques for server-side rendering. Little applause for Robert Aritonov.
Thank you, team, for your introduction. You saved my time since I have only 6 minutes, so that's really great. So yeah, as you can see on my double-side badge, unique double-side badge, I'm both the organizer and a speaker. I wasn't really pleased to do that in 1 week with preparations of everything at once, so please bear with me if I'll have some hiccups during the slides. It was really hard and tense to prepare in my schedule. But nevertheless, I want to tell a bit of a story of how we've been approaching the advanced server-side rendering caching with React, which findings we got, and what you can reuse from our experience. And without further ado, let's just jump into details, as again, I have just like 5-6 minutes to not postpone everybody else. So to give you a bit more context, Zuber is a travel website, mostly aiming at the Dutch market. And it's a fairly high-load project with around 3-4 million visitors a month, especially in high seasons, and around 350 requests per second on higher load. And that will be only growing from now on, because we're really ramping up everything right now in the product. And to give you, again, even more context about why server-side rendering is super important for us in general, and might be for you as well, because our project is not that unique in the way how we get visitors and so on, is the fact that around 80% of traffic we get for the website is coming from Google. And you may ask that if Google already executes JavaScript, then what's the point of struggling with server-side rendering performance and things like that? But considering the huge amount of traffic going from there, we can't afford any hiccups, and we can't afford any fall downs in responses and queries from and the results from Google. So because every position would just directly affect our revenue. So it's super important to give as much content to Google as possible. And of course, React is really great with that. We're really thankful that React allows to write isomorphic applications, which we do in our project as well. And the problem is that server-side rendering, although it's there and it's great, it's quite long to execute on server, and especially on in container environment where we have a lot of machines with smaller CPUs. You can definitely feel that, and I'll show you some numbers a bit later. It's still, of course, great that it's there, that the possibility is there, because without it, yeah, we won't be using most likely React because it just won't fit. But again, it's sad that the community is not giving that much attention to it, therefore it's not that optimized yet. But the things are getting better, and again, more details on it. So first thing that you can think of when you talk about optimizing the server response times is probably caching. But of course, you first optimize your code, so everything is working just more efficient, and then caching, because caching is in general really hard to manage. But also with caching, even if you reach the point and you find your safe strategy to do caching, it's really hard to choose what exactly you would like to cache. So the most efficient could be caching the whole page response. And at first sight, it might seem that you don't have any personalized data, you serve only public pages. But then if you look closer, you see that you have some A/B tests running, you have some real sensitive data that should be updated more often. And if you'll fail, you can have really bad issues like Steam had some while ago with showing other people pages to like other random strangers with some personal data and so on. So it's really easy to fail. The next thing that you probably will aim at when you talk about caching would be caching data, like queries to database, which is a lot easier to manage, and it's a lot more straightforward. But again, it won't solve a problem of slow server-side rendering, because even if the data will come fast, and still React will take like up to 200 milliseconds to render, you still lose a lot of time. So the most efficient approach you can get with React is to cache on component level. This gives a lot more flexibility of what exactly you want to cache, what you don't want to cache, and so on. And as I have just 2 minutes left, I will try to run a bit faster through the solutions. So one of the biggest players with server-side rendering at scale is Walmart, a real super popular project with a really big high load. And they have a really interesting open source project like Electrode, which is a common solution for developing React apps, but they also have like the smaller modules that do specific things, like Electrode React Assessor caching. It allows you to do profiling, to exactly determine what's wrong and what's the slowest in your project. Then it allows also to do per component caching and some templating, so you can cache less, but use more optimized ways of replacing the strings, not calling the React renderer as much as possible. And yeah, as I promised, here are some numbers, what you can achieve. So given that 200 milliseconds could be the initial average response time from the server, caching just data, you can achieve around 50 milliseconds. But rendering also the results of server-side rendering, you can go even to 15 milliseconds, which is a lot greater, and of course will provide better user experience for your clients. Talking about code examples, it's quite easy to configure the per component caching. Basically, you can just define a list of components and the strategy of how they should be cached. And in our case, we are aiming at caching per route components, which again with React Router is real straightforward to match the things. And it could seem that, yeah, you just took the solution like this and you're all good, but it's not that easy because there are some catches. And the other project that I found really recently from Formidable, thanks a lot for them for this project, is solving most of the problems that are there with traditional server-side rendering caching approaches for React. And how Rapskillian is different from Electrode solution is that, first of all, it's asynchronous, which allows you to cache on remote servers, which is super great and allows you to have common cache for clusters. It supports the external servers, and it also can do the streaming, which was previously possible only with like complete forks of React, but with this you can just get it almost for free and super easy to use. And again, as I don't have much time, I'll just show you some slides, which you will be able to get from internet. The ease of use is just really great. You just replace render to string function with render from Rapskillian, and you can easily synchronize the rendering. And the syntax is also a lot more nicer of how you define which components and how do you cache them with which strategy, just setting it straight in JSX. And yeah, asynchronous rendering opens a lot of possibilities to render for cluster without keeping the state per application. And to wrap up, the last thing I want to mention, the thing that we are building is still in beta. We're just now rolling out to test it on real users. But having those insights could be really useful and beneficial for you as well. So if you're into those kind of things, join us at our challenge. And as any other company in the Netherlands and the world, we're also hiring. And we also have a booth, so come by. I'll be there to answer more questions. And yeah, hope our insights were quite useful for you and you can reuse some of them as well. Thank you.